The first problem is this. What is the future value of $70 invested at a continuously compounded interest rate of 4% per year after 3 years? So A is your $70. That's what you start off with. The continuously compounded interest rate in this problem is given to you. It's 4% per year. 4% per year compounded continuously. Okay. And T is the amount of time in years, 3 years. So you just plug in and you calculate V of 3 is going to be 70 times e to the 0.04 times 3, 70 times e to the 0.12 power. And what do you get when you do that calculation? Just give me to the nearest penny. Okay. Anybody? To the nearest penny, what is this going to be? Yes, I got 70.92. Let's just double check that. All right. So what do you get when you take 0.12 and then you raise it to e to the 0.12 power? I get 1.12749,685. Okay, and then multiply that times 70, and I get a 78.92 to the nearest penny. If you round off to the nearest penny, 92. Okay. All right. Matthew, did you? Now you got something different? Oh, Johnny. I'm sorry, John. Okay. All right. Okay. All right. So you ought to be able to do these calculations. Okay. By the way, this problem 3 on page 267 involves money invested at a continuously compounded interest rate. But these problems are obviously can be expanded to other areas. For example, suppose this V represents population and A represents your present population. Assuming the population is growing at a constant growth rate of R per year, then this could be interpreted totally different. At the end of 3 years, your population would be, instead of 70 million, it would be 78.92 million. So these problems can be interpreted in areas, obviously, other than finance. Okay. The key assumption here is that this R is the instantaneous growth rate of this variable here. Now, an R in finance problem is the continuously compounded interest rate. But more generally, it's just the instantaneous growth rate of your dependent variable. So you could change this to population if you wanted to. And you start off with 70 million at the end of 3 years. If your population is growing continuously at 4% per year, you end up with 78.92 million. Or if V is GDP, and GDP is growing continuously at 4% a year, at the end of 3 years, this 70, say, $1 billion of GDP would be $78.92 billion. So it obviously can be interpreted many other type of problems.